So we need to simplify this problem. So we're going to do a number of things. I see a couple of terms here that are squared. So remember, when something is squared, what that means is we can rewrite those terms twice, and we multiply them by themselves. So 3 minus 2i times 3 minus 2i. And I see a plus sign in between, and I'm going to do the same thing with the 4i cubed. Since that's squared, that means that I can also write that twice. So 4i cubed. And I see another plus sign. Now I see conjugates here at the end, 5 minus 3i and 5 plus 3i. So let's just write those down for right now, and we'll distribute in a second. So 5 minus 3i times 5 plus 3i. All right, so let's start by double distributing. So if we look at the first one, we're going to multiply the 3 times the 3, which is 9, and the 3 times the negative 2i, and then 3 times another negative 2i. So each of those 3 times negative 2i's is going to be negative 6i. So if I do that twice, that's going to be negative 12i. And then we would multiply the last two terms, which would be plus 4i squared. All right, let's move on, and we have a plus sign here. So now here I'm going to multiply the 4 times the 4, which is 16, and I cubed times I cubed. Now remember, when you have the same base, you just add the exponents when you're multiplying, so that would be I to the 6th. All right, now let's go down here to the end. We have conjugates. Remember, that conjugates mean essentially that we have the same thing inside the parentheses, except that the sign in the middle is changed. So you can look at this and you can say, well, if I have conjugates, then I know I really only need to multiply the 2 first terms and the 2 last terms, because my middle terms are going to cancel out. If you forget that, just double distribute. I'll double distribute just so that you can see why we can take the shortcut. So 5 times 5 is 25. And I have a plus 15i times a minus 15i. So plus 15i and then minus a 15i. And then lastly, the 2 last terms, which is the negative 3i times the positive 3i, which is negative 9i squared. So this is why with conjugates we can really just skip this middle part here, because that's going to cancel out. But again, if that's confusing, I would just skip it. All right, next. So we have 9 minus 12i. Now, when we get here, you have a calculator. You can put I squared into your calculator, and you're going to see it's negative 1. So we have 4 times negative 1 plus 16. Same thing. Put I squared in your calculator. That's also going to be negative 1. And let's bring down the plus 25 minus 9. And again, I squared is negative 1. So now, let's just simplify a little bit more. 9 minus 12i. That's going to become a minus 4, a minus 16, a plus 25, and then negative 9 times a negative 1 is a positive 9. All right, so the only odd man out here is this term right here. So what I'm going to do is I'm going to do 9 minus 4 minus 16 plus 25 plus 29. And when I do all of that, I will get 23. And then minus 12i, and ding-a-ling, there we go. So that is our answer, which is choice 2. Number 2 is asking us to find the solutions. And if I look at the 4 choices, I see that those are kind of set up in a form that would make me think that I need to do the quadratic formula. So what I'm going to do is I'm going to take this equation, and I'm going to get everything to one side, set it equal to 0, and do the quadratic formula. So I'm going to start by moving this 2x over. So I'm going to negate that. And I am also going to subtract 10. Oopsie, I'm going to squeeze that in there. Okay, so over here, those will cancel out. And on the left side, I'm going to get x squared minus 5x. And that is going to be minus 5 equals 0. All right, so now I have it where I have my trinomial set equal to 0, so now I'm going to do the quadratic formula. So remember, x equals negative b. Well, regular b is negative 5, so negative b would be positive 5. Plus or minus square root, and then it's b squared, which would be negative 5 squared, minus 4 times your a value, which is the number in front of the x squared, which is 1, times your c value, which is the constant at the end, which is negative 5. And the whole thing is over 2 times a, and again, a is that number in front of the x squared, which would be 1. All right, so let's just do a little bit of simplifying here. So I have 5 plus or minus, let's make that look like a plus. All right, so underneath the radical, I have 25, and then I've got a negative 4 times a 1 times a negative 5. Now that's going to be 25, and that negative times a negative will become a positive 20, and that whole thing is over 2. All right, so underneath the radical here, if you look, we have 45. Remember that 45 can be broken down. So we can break that down to two numbers that multiply to 45, where one of them is a perfect square, and there we go. So 9 and 5. So then we have x equals, we've got 5 plus or minus the square root of 9, I'm looking down here, okay, which is a 3, radical 5, and the whole thing is over 2. Okay, and then what we do is we just go right up to our multiple choice answers, and we will see that that is choice 1. All right, well, ignore my theta. It's beautiful, isn't it? So they're giving you that tan theta is equal to 15 over 8, but they're also telling you that theta lies in the third quadrant. So what I would probably suggest that you do is draw yourself third quadrant, and remember that tangent is equal to the opposite over the adjacent. Oops, let's make that look like a D. Okay, so I'm going to draw my triangle in the third quadrant. Remember, theta will always be right over here at the origin. Okay, and tangent is the opposite, so I'm going to go opposite theta, which will be right here, and adjacent, which will be right there. Okay, so basically what I need to do is I need to find this hypotenuse right here, and I can do that in one of a couple of ways. If I know my Pythagorean triples, I would know that that's 17. Now, if you don't know your Pythagorean triples, you can just do 8 squared plus 15 squared equals c squared, and you can solve from there. So that would be, oops, yikes, 64 plus 225 equals c squared. Okay, and then all you have to do from here is just do your 64 plus your 225, which is going to be 289. And that's going to give you, oops, come on, stylus. That's going to give you c squared. And we take the square root of that, and then you will get 17 for your c value. Okay, now if you look at the question's asking you to find the value of sine. Now remember that sine of an angle, and I probably should have threw that in there too, is equal to the opposite, right, SOHCAHTOA, over the hypotenuse. So if I look at my triangle and I look at the opposite, then sine theta is going to be the opposite, which will be 15, over the hypotenuse, which will be 17. Now we do need to take into account that we are in the third quadrant, and sine is negative in the third quadrant, so we want to make sure that we negate that fraction. And that would be our answer there, which is choice number 4. So for number 4, what we're trying to do is solve for x. And the first thing that we're going to do is we're going to get rid of that square root. So remember, we do the opposite of square rooting, which would be squaring. So on the left side, we're going to cancel out that square root. We're going to get negative 3x plus 27. Yikes. Trying to get that to be a 2 and not a plus, but okay, now on the right hand side we've got to double distribute. So x minus 3 times x minus 3. Okay, so that's what we're going to be doing. So when we do that, we're going to get x squared. And then we're going to get minus 3x and minus 3x. So that's going to give us minus 6x. And then a negative 3 times that negative 3 is going to be a positive 9. There we go. Okay. I like to get everything to one side and set it equal to 0. So I'm going to add this 3x over, and I'm going to add it to the 6x, get the like terms together. And then I'm going to subtract 27, and I'm going to subtract 27 and get those like terms together. All right, so the left side is going to just become 0. I'm just going to flip it around. So that's going to give me x squared minus 3x, and then that's going to be minus 18. And we're going to set that equal to 0. All right, now we can factor. So that's going to be x minus 6. And we're going to get x plus 3. Oops. Okay. And when we solve, we get x equals 6. And we get x equals negative 3. Okay. Please be careful and make sure that you check these two answers back into the original given equation. Because the problem is, I'm just going to show you on the right-hand side, when you do that, when you plug in a negative 3 into that original, you're going to get negative 3 times negative 3, which is positive 9, plus your 27, and that's supposed to equal negative 3 minus 3, which it's not going to, because 9 plus 27 is 36, and the square root of 36 is 6. However, that does not equal negative 3 minus 3, which is negative 6. So, therefore, x equals negative 3 cannot be an answer, and x equals 6 is an answer. So, check it, you'll see, and it'll be choice 3. All right, so we're basically trying to simplify. Now remember, when we have negative exponents, if we're raising a fraction to a negative exponent, to make that exponent positive, all we have to do is we're just going to take this and we are going to flip it. So we're going to write 125 over x cubed. Now there is a negative there. I'm just going to put that in the middle there. Oops, let's make that look a little bit thicker. So there's the negative. And now what that does is that's going to make that to the positive 2/3 power. Okay, so we just got rid of the negative. Now we have to get rid of that fractional exponent. Now I don't know if you remember that we have power over root. I hope you remember anyway. So we've got power over root. So what we're going to do now is we are going to take the cube root of negative 125 over x cubed. Okay? And then after we take the cube root, we'll deal with that first, but then we're going to square it. All right, so what we're going to do is we're going to take the cube root. Now, you can use the cube root button in your calculator, and the cube root of 125 is 5. And the cube root of x cubed would be x. And the cube root of a negative number would be negative. Now, we're going to take that value, and the last thing we're going to do is we're going to square it. So we're going to square the numerator, square the denominator, and don't forget to square that negative. So if we square the negative, that's going to become positive. And if we square the 5, we're going to get 25. And if we square the x, we're going to get, x squared. And there's our answer. And we look at the multiple choice, and that is choice 1. For number 6, they're talking about the focus and the directrix, which means that we have a parabola here. So I'm going to start by trying to get this equation to say y equals. So I'm going to start by dividing that 8 out. Now if I divide by 8, I could also multiply by 1/8, which is what I'm going to do. So I'm going to write 1/8 x minus 2, that quantity squared, equals, and if I multiply the right side by 1/8, I'm just going to get y minus 3. Okay, so now I've almost got the y by itself, so I'm just going to add the 3 now in the next step. So 1/8 x minus 2, that quantity squared, and I'm going to add 3. And that is going to give me my y value. Okay? Now, I don't know. Since the equation takes this form, then we know that we have a parabola that opens up. So when we look at this, we can see that this value right here represents 1 over 2p. So this is 1 over 2p. And p represents the distance from the focus to the directrix. Next, if we look at these values here, they represent what we call our h and our k, which are the coordinates of the vertex of the parabola. So we always change the sign of what's inside the parentheses, so that's going to be a positive 2, comma, 3. So those will be the coordinates of my vertex. Now, just to kind of backtrack, just remember that this particular parabola, since it does open up, the equation that we use is 1 over 2p, and then it's x minus h, that quantity squared, plus k. So that's where I'm getting this from. The h being the x value, the k being the y value for the vertex. Now, just to kind of explain a little bit further, just in case you're confused, let's look at a picture, because I think that might be a little bit more helpful. So if we look at this, okay, let's just go out 5 here. 1, 2, 3, 4, 5 there. So our vertex is 2, 3. So that is basically the turning point, so to speak, of our parabola. So there's the vertex, 2, 3. And because, again, we have an upward pointing parabola, it's going to look something like that. Okay, now let's get to this p. So p is the distance from the focus to the directrix. So in other words, from this point right here, what I'm going to do is I'm going to go up 2, and I'm going to put a dot, and I'm going to go down 2 and put a dot, because that total distance is my p, and my p is 4. So remember, the directrix is a line, and that line cannot cross the parabola. So obviously then our directrix can't be right up here. So our directrix will be the line that goes like this. Okay, and actually let me just, so there is our directrix, and our directrix is the line y equals 1. So our focus is going to be this green point up at the top, and the coordinates of that point is 2, 5. And then that makes that choice 3 as your answer. They want to know which of the 4 is not equivalent to 36x cubed. So what I'm going to do first is I'm going to try to figure out what 36x cubed underneath that square root really is. So what I'm going to do is I'm going to break this down. And I know 36 is a perfect square. And I can break x cubed down to x squared and x. Let me just make, there we go. All right, now I separated that because on the left, those are my perfect squares, and on the right, those are not my perfect squares. So the square root of 36 is 6, and the square root of x squared is x. Now, I have a radical x, which I can't really do anything with. So this is what I'm looking for right here. Okay? If it matches that, it's not the answer. If it doesn't match that, it is the answer. Well, look at choice 1 right here. Choice 1 definitely matches it. So that cannot be the answer because they're asking for which one is not equivalent. All right, so let's look at choice 2. So I would kind of do the same thing as what I did in part 1 for choice 1. Or actually, so let me think. Okay, so let's do it this way. So I'm going to break it up like I did actually in the original. So I'm going to make it 2 square roots. And I'm going to put 144 here. Oh my goodness. Sorry about that. My stylus does not want to cooperate. And then x to the 5th, I can break that down to x to the 4th. It's supposed to be a 4. And then over here, I'm going to put x. Okay, I'm sorry that that's so sloppy looking. But the square root of 144 is 12. And the square root of x to the 4th is x squared. Okay. Then I have radical x. Now, I'm not neglecting the fact that, yes, there is a denominator to all of this, but I was trying to simplify the numerator first. Now let me throw that 2x back down there. And now you should be able to simplify what's on the outside. So 12 divided by 2 is 6. X squared divided by x is x. And then we bring that radical x along for the ride. That matches what I have up in the top there in the box. So, like number 1, number 2 can't be the answer either. Okay, so let's look at choice 3. Choice 3, everything is underneath the square root here. Remember, when you have any kind of an operation underneath the square root, you can perform that operation. So for example, I can do 72 divided by 2, but what I'm going to do is I'm just going to keep it underneath the square root. So that's going to give me 36. And the same thing when I have x to the 5th divided by x to the 2nd. Remember, when you have the same base, you can, and it's division, you can subtract the exponents. So that's going to be x cubed. Now I'm just going to stop right there. I can simplify that if I want, but if I look, that is the same thing as what I started with right there. Okay, and again, they want to know which one is not equivalent, so we know it's not that. So process of elimination, obviously choice 4 is the answer, but let me just kind of explain a little bit further. So if I do 3/2 times 24, that's going to give me 36, and then we've got x to the 4th, and that whole thing is over a plain old regular x. Now, 36x to the 4th, those are perfect squares, so I'm going to take the square root of 36, which is 6, and the square root of x to the 4th, which is x squared, and then it's all going to be over x. And I can simplify that one more time, so that's going to be 6x, and there's your answer. And that does not match what is up in the box right there. So since that's not the same, choice 4 is your answer. That's going to give me x squared, and then the x times the 2, which is going to give me a positive 2x. Now this is where we kind of differ a little bit. Mrs. Paris's kids, you guys all just change the signs. My class, what we do is we just throw a negative there and then just subtract through. Any way you look at it, when you end up doing that, you should end up with a negative 10x. Okay, if you change all the signs, you'll get negative 10x. If you distribute the negative through, you'll get negative 10x. And then we drop down that plus 12. And then we repeat it again. So we say, what do I multiply x by to get to negative 10x? And that would be negative 10. So I multiply that by the x all the way in front, and that's going to give me negative 10x. And I multiply that negative 10 by the positive 2, and I get negative 20. So again, Mrs. Paris's kids, you may like to just change all the signs. I distribute the negative through, and when we end up with that, either way you look at it, you get a positive 32. Now that's your remainder. So remember, when we have a remainder, and I don't know that I'm going to be able to fit this into pretty looking, but you take that remainder and you're going to put that as a numerator, and you're going to put it over what we just divided by. So there's our answer. Let me rewrite it down here so it looks a little prettier. So x minus 10 plus 32, and that's going to be over x plus 2. Okay, and that is choice 4. So I wrote down the sum formula because they want the sum of the first 4 terms, giving you a sub 1 and giving you the r. So what we're going to do is we're going to start by putting in the a sub 1, which is pi plus 3. So we're going to write pi plus 3. Now it says minus. I'm going to open up a set of parentheses because I have a binomial and there's a minus sign there, so we're just going to leave that. Now our r is 4, and we want to raise it to the n power. Now n stands for the number of terms we have, and they are asking for the sum of the first 4 terms, so we're going to raise that 4 to the 4th power. And then all of this is going to be 1 minus 4. Okay. So what I would probably suggest that we do, and let me see if I can squeeze it in over here, is let's just bring down that pi plus 3. And then what I'm going to do is I'm going to write minus. I'm going to leave that pi plus 3. And I'm just going to do 4 to the 4th power. Okay? So when I do 4 to the 4th power, I'm going to get 256. I don't think I'm going to be able to fit that, so I'm just going to squeeze it in up here, and I'll draw a little arrow, so that's what's supposed to go there. All right, let's bring it down over here. And then, of course, obviously, that's over 1 minus 4. Let's make that negative 3 while we're at it. All right, so I'm going to, again, just leave that pi plus 3 for right now. So that'll give us pi plus 3. Oh, look, we changed colors. Now, what I'm going to do is I'm going to distribute that 256 through. I'm going to keep that minus, so that would give me 256 pi. And then we're going to get plus, and when we distribute that through, we're going to get 768 if we multiply the 3 times the 256. And again, remember that this whole thing is over negative 3. All right, so now let's distribute the negative 3. I'm sorry, the negative through. So that's going to give us, so we're going to distribute the negative through, and we're going to get pi plus 3 minus 256 pi, and then we're going to get negative 768. And that whole thing, again, is over negative 3. All right, so let's just simplify our numerator there. So when we simplify the numerator, it doesn't matter what you put first. I'm going to come down here to the bottom, and I'm going to put negative 765. And then I'm going to put negative 255 pi. So you can put the pi part first, or you can put the whole number part first. It doesn't matter. And we're going to divide by negative 3. So now I'm just going to divide the negative 3 through to everything in the numerator, and that's going to give me a positive 255, and that will give me a positive 85 pi. And that is choice 3. 10 is asking us to find the value of x. So if we look at this question, we just need to divide by 5. So I'm going to divide the left by 5 and the right by 5. And that will cross out that 5 on the left-hand side. So I have x equals the ln of e to the 16th, and that over 5. Now let's remember that an ln and e cancel each other out. So that's going to disappear, which is really then just going to give us 16 over 5. And then throw that into your calculator, and that would be 3.2, which is choice 3. For this question, they want you to find the margin of error. We can look at this in two different ways. We do have a margin of error formula, if you recall, and that margin of error formula is margin of error is equal to 2 times the square root of p times q over n. Now, in this case, our p would be our mean, which is our proportion of successes, okay, your success rate. So, to find our margin of error then, we would do 2 times the square root of, now we want the proportion of our successes, which would be our mean, which would be 0.32. So 0.32. Now remember what Q is just 1 minus that 0.32. So that would be 0.68. And then N stands for, in this case, our sample size. And our sample size that they gave us was 50. So we're just going to throw that into our calculator, and you're going to do 0.32 times 0.68. Get that answer, divide it by 50, and take the square root of that, and multiply it by 2. When you do that, you're going to get 0.1319. And if you look at that, rounded to the nearest thousandth, you're going to see that that's 0.132, which is choice 3. Now, we would use this method. Sometimes what's going to happen is if you aren't given the standard deviation, this would be the way that you're going to go. Because sometimes what they'll do is they'll give you the probability of success of something, let's say, is 0.42. And in that case, that would go in for your P, and then you would do 1 minus 0.42 and get 0.58, and that would be your Q. Now, I think for this particular question, there's another way to go about it. I find it easier, you may not, and that's totally fine if you don't want to do it that way. Remember, margin of error really is just our 95% confidence level is 2 standard deviations away from the mean. So since they gave us our standard deviation here, really all we have to do is multiply 2 times that standard deviation. Now I want to talk about that standard deviation because the standard deviation that they gave you in the actual question is incorrect. It says right now that it's 0.66. It should be, that's a typo, that should be 0.066. Okay, so if you would make that change on your paper, the third line down in the middle, it says the standard deviation is, would you change that please to 0.066? So change that on your paper. Now, because they give you the standard deviation, it's very simple. All you need to do is multiply that by 2, and if you do that, you're going to end up with 0.132. And you're done. Again, answer's choice 3. So I think that that's a quicker way to go when you are given the standard deviation. But if you're not given the standard deviation, then you would have to go with this way right here. They're giving us the probability that an event will occur, and they want the probability that an event won't occur. So for example, if the probability that it's going to rain is 20%, then the probability that it's not going to rain is 80%. And the way we do that is we take our 100, which is our total, and we would subtract 20% from that, and that's how we would get 80. So our total here is 1 minus 2 over x plus 2. So this will give us essentially the probability that this event won't occur. Okay? All right, now, so if we look at the expression on the left, we see that we need to find a common denominator. So I am going to multiply the numerator and the denominator on the left by x plus 2 and x plus 2. No, that does not look like an x plus 2. There we go. A little bit better anyway. All right, so in that case, I'm going to get x plus 2 minus 2. And that whole thing is going to be over x plus 2. And then we see in the numerator that those 2's are going to cancel out, so I just have x over x plus 2. And if we look at our choices, that is choice 4. So what I did was I went through each graph and I described whether it was odd, even, or neither. Now, this one, number, well, it's not even a number, f of x, let's call it, is even, because remember, even is symmetric with respect to the y-axis. So if you were to fold your paper along this y-axis here, you're going to see that the left side of the graph matches up with the right. Okay, so that makes that even. If we look at g of x is odd, and odd is symmetric with respect to the origin. Basically what that means is if you take your picture, the g of x picture, and you turn it upside down, it would look the same as if it was right side up, so that makes that odd. Now h of x is neither, because you can't turn it upside down and have it look the same. It would be an upside down parabola, not a right side up one. And also it's not even, because if you go along this y-axis right here, you see that the left side of the picture certainly does not match up to the right side. And then over here, the last one, j of x, that one's odd. Again, it's symmetric with respect to the origin, meaning if you turn it upside down, the picture that you look at upside down should look the same as right side up. So now if you go through your choices, you'll see choice 4, both g of x and j of x are odd functions, is the correct response. For number 14, what they want you to find is the inverse. And remember, inverse just means to switch the x and the y. So let's start with the fact that p of x right here is just a fancy way of saying y. So if I want to find the inverse, what I'm going to do is I'm going to switch my x and my y values. So this says y equals, so I'm going to write it as x equals negative 3/4, and instead of writing x, I'm going to write y plus 5/6. All right, so what we did was we just found the inverse. Now when we find the inverse, not only do we want to switch the x and the y, but we want to get the y by itself. So I'm going to start by subtracting 5/6 from both sides of the equal sign. So I'm going to get x minus 5/6 equals negative 3/4 y. So I'm getting closer to getting that y by itself. The problem is I still have the negative 3/4 there. So if I multiply by the reciprocal, that will cancel that negative 3/4 out on the right-hand side. And what I do to the right-hand side, obviously, I need to do to the left. So I'm going to multiply by negative 4/3 here as well. All right, so let's just distribute that. I think I'm going to scoot over here so I don't run out of room. If I distribute that, that negative 4/3 through, I'm going to get negative 4/3 x. And a negative times a negative will give me a positive. And I'm doing negative 4/3 times negative 5/6. So the negatives will cancel out and become positive. And then I'm going to have 20 over 18. Multiply numerators with numerators, denominators with denominators. And that will equal y. Okay, so let's just go a little bit further here. So we're going to have negative 4/3 x plus, and we can divide both the numerator and the denominator by 2. So that would be 10/9. Now that equals y, but remember what we did was we changed p of x back here in the very beginning. We changed that to y. So let's change that back to p of x. But remember it's the inverse now. So we denote that by a little negative 1 power. And there would be our inverse. Oops. There we go. And then if you look at your choices, that would be choice 2. They want us to find the nature of the roots, which is going to require us to get x by itself. So let's start by distributing the x through, and we're going to get x squared plus 10x equals, and let's distribute that 5 through, and then we're going to get 10 minus 5x. I would like to get everything to the side with the x squared, so I'm going to add 5x, and I'm also going to, just at the end here, I'm going to subtract this 10 over. I'm just going to draw a little arrow, otherwise it's going to get a little ugly looking. Alright, so then what that gives me is x squared plus 15x minus 10 equals 0. Now, we can look at this as one of two ways. We could do the whole quadratic formula, or if we look at the nature of the roots, really what we have to do is just look at the part that's underneath the square root, which is the b squared minus 4ac, because that will give us the nature of the roots, and I'll go into that a little bit more in a second. So if we look at this, our b is 15 right here. That's our b. So 15 squared minus 4, our a is 1, that's the number in front of the x squared, and then our c is the number at the end, which would be negative 10. All right, so 15 squared is 225. And then I have a negative 4 times 1 times negative 10, which is plus 40. And if I keep going with that, I will get the square root of 265. So let's talk about that. So the square root of 265, well, that's not a perfect square. So when something is not a perfect square, and it's positive, we say, I'm going to abbreviate here, that it's irrational, which would be choice 2. Okay. Now, let's just take a moment, though. So, for example, let's look at choice 1. Choice 1 says 2 rational and unequal roots. And I'm just going to go like this. Choice 1. So let me just back up a second here. This is our answer, by the way. Okay? If you do not get a perfect square, we consider that what we call irrational, a positive perfect square. All right, now let's look at choice 1, though. Choice 1 says 2 rational unequal roots. That would be like if I had the square root of 16, or if I had the square root of 121. Those are all perfect squares. So positive perfect squares. So positive perfect squares would give us rational unequal roots. Okay, let's look at choice 3. Choice 3 says equal roots. That word right there, equal, means the only thing that we could get underneath the square root, or discriminant, would have to be 0. So equal, that's all you can get. It's just the number 0 underneath the square root. And then if we look at choice 4, it says 2 imaginary roots. Imaginary would mean that anything underneath that square root would have to be a negative number. Like, it could be negative 16. Okay, remember we know that to be 4i. Or it could be negative 265. The same as what we got as our answer, except negated. So with imaginary roots, the big thing is it's got to be a negative number. So what I did here was I went into my calculator and I took this equation and I put that in my y1. And I took this equation and I put it in my y2. And I did a zoom 6. And you can see the picture over there on the right. So basically what they're asking for in number 16 is find the x values that satisfy the equation where f of x is equal to g of x. So what they're looking for is where they intersect. Now if you look at the picture, that would be right there. So you're going to do second calc, intersect. So if you do second calc, intersect, this point right here ends up being 2.5, comma, 3.5. Again, second calc intersect. And if you read the question, they are asking for the x values that satisfy the equation. So my x value is right here, so my x value would be 2.5, which is choice 4. Now just a reminder, one of the ways that you can find those absolute value brackets in your calculator is when you hit math, you arrow to the right to num, and you'll see it right there. It's number ones, and just hit enter. For 17, they're asking you to find the solution set. So what I did was I took this entire equation and I put that into my y1 and I graphed it. I did a zoom 6. Now look at my picture on the right. It's not a complete picture, but if you look at it, when it asks you to find the solution set means to find out where they hit the x-axis. So I mean, I know that my picture, if I look at it, it does go all the way up, and you can kind of see that little maximum up there. And we're missing the minimum, but again, I'm just looking for where it hits the x-axis. So that would be here, here, and here. Now I need to find out specifically where those values are. And unfortunately, you can go to table, and you can look for where the y values are 0, but you're only going to see 2 solutions there. The problem is you will not see, and I think it's this one right here. That one you're not going to see in your table because it's not a whole number. Okay, so if you do decide to go to table, you'll see that 2 of your solutions would be a positive and a negative 4. Okay, because their y values are 0. So what I did with this little pesky one over here is I did second calc, second trace, and I went to 0. And remember, you move your cursor to the left a little bit, hit enter, move your cursor to the right a little bit, and you hit enter twice. And when you do that, you will get x equals negative 1.5, which is negative 3/2. So with this one here and this one here, those are your solutions. And then if you look at that, that is choice 4, which is the negative 3/2 as well as the plus or minus 4. So that's where the graph hits the x-axis. Okay. So we need to find the value of this expression over here on the left, and they gave you this triangle over on the right. So if we look at the sign of A, here's A. Remember that the sign is the opposite over the hypotenuse. So I'm going to have 15 times the sine of A. Now the opposite over the hypotenuse would be 8 over 10. Plus, then we're going to have 10 times the secant of B. Now we need to remember what goes with secant. Okay, so the reciprocal trig function for secant is cosine. So I'm going to find the cosine of B. So here's angle B down here, and cosine is the adjacent, which is 8, over the hypotenuse, which is 10. Now, if the cosine is 8 over 10, then that means, remember the reciprocal trig functions, we would just take the reciprocal, which would be 10 over 8. So in here, I'm going to put 10 over 8. Okay? All right, next, minus 8. And likewise, now we have a reciprocal trig function, again, cotangent. Well, cotangent goes with tangent. And the tangent of A, let's go back to this angle up at the top here. Tangent is opposite over adjacent, which would be 6. Okay, so then if I want cotangent, which is its reciprocal trig function, I'm just going to flip 8 over 6 and make that 6 over 8. And then that is what's going in over here. So I have 6 over 8. All right, so let's just do a little bit of math magic here. We're going to do 15 times 8/10, which is going to be 12, plus, then we're going to do 10 times 10 over 8, which is 12.5, minus 8 times 6 over 8, which is 6. And when we add that all up and subtract, we get 18.5, which is choice 3.